Hello everybody, this is the retake video for one-step equations, and we are solving these equations using algebra tiles. So before we get started, let's review what an equation is and what algebra tiles are. So an equation is any mathematical representation where two values are equal, okay? Which means that we need an equal sign in order to be working with an equation. A variable then is a mathematical symbol that can represent any number. So b, x, y, any of these can represent any mathematical number. And the word variable means to change, which is why the numbers can change into whatever number we need. Okay, on the right side, we have the algebra tiles that we're working with here. A positive one and a negative one add together to create 0, which is very important as we solve these equations. And then a positive x can represent any number, and a negative 1x represents the opposite of that number. So if positive 1x is equal to negative 6, negative 1x would be equal to positive 6, and that will come into play on this video. Okay? Let's get started here. So our first problem on the left is 2 plus y is equal to negative 4. First step for any equation, I like to draw a line down my equal sign to separate the two parts of my equation. And then I just have to represent what I see. So on the left side, I have positive 2. And I have a positive variable. Just because it says positive y does not mean that I would need a different algebra tile for that. On the right side, I have 4 negatives. And my goal is, what does a single x equal? What does 1x equal? So I said in the other video, thinking of it like Mr. Schmidt at lunchtime, he just wants to be left alone. So how can we get rid of all of the things that are on the same side as the variable? Well, first step would be getting rid of these two positives, which I would just add to negatives, because I'm going to create 0 there. But rule of equation is if I do something to one side, I have to balance the equation and keep it equal on the other side. I get rid of that. And on the left side, I have 1x or 1y, depending. And on the right side, I have negative 6. And I am done. Okay, there are a couple different ways to solve this problem. I believe what I just did on the screen is the fastest way. And I do believe it's the way that's easiest to follow later. However, if you have a different method that is mathematically correct, just make sure you okay it with your teacher. From this next step of the equation, the one on the right here, I'm going to draw my line down the equal sign like I've done before. And I'm going to add 9 positives to the left side here. So 1, 2, 3. It's very hard to count and talk at the same time I'm learning. So if I miscount, I was one short. So close. I was going to say that you cannot make any fun of me, and I'll stand by that statement. Mr. Schmidt's a very serious guy, so no poking fun here. Alrighty. We have positive 9 on the left. We have positive 3x on the right. So the question is, what does each x equal? So the way that I like to think of this is I split them into equal groups. So each x into its own group. And I simply separate the numbers so that every group has the same amount. And when I do that, I get positive 3 in each group, meaning that a positive 1x is equal to a positive 3, and these two equations are done. Let's do 2 more, and then we will send you off to practice. The problem on the left is the first one that will require us to use a negative x. So it will look a little bit different, but the math process should be the same. So I have 5 minus x. One of the things that I always teach my students, we call this Ann's method. I had a student when I taught in South Dakota who hated variables that were left alone. So she would always write ones in front of them because a single x and one x are the same thing. And I think that's helpful for this type of problem. So I'm going to do positive 5 chips on the left side, and then 1 negative x on the left side. And on the right side, we need 9. Okay. So now again, we need to get our x alone. Just because it's a negative x does not mean the process to get it alone is any different. So I ask myself, what's on the same side as the x, which in this case is positive 5 chips. And then the opposite of positive 5 chips would be negative 5 chips. And just save space. We're going to crowd them a little bit, but I need to do negative 5 chips to both sides of my equation because I need to keep it equal. And now we can create some zeros. Now, all of these can become zeros, so I'm going to simply delete them here. Save some space. There we go. A little bit of hand-eye coordination here I didn't know I had. There we go. And we only have a negative x left. And on this side, we need to get rid of all but 4 because we created 5 zeros. Now, here's the part that's new. We have a negative 1x is equal to a positive 4. In order to change this to a positive x, I make this side of the equation opposite. So then I would need to make the other side of the equation opposite as well, which means my new answer would be positive 1x is equal to negative 4. Same process, just with an extra step at the end. Let's do one more, and then we will be done. So over here we have, whoops, let's try that again. We have negative 4 plus Ann's method, 1c is equal to negative 1. So I'm going to take 4 negative chips, put them over here on the left. I have a positive variable. I'm going to put that on the left. And I have 1 negative chip on the right. Something we've done many times by now is I want to do the opposite of this, which would be positive 4 chips. And we need to do that to both sides. I'm going to save a little bit of time here. Try and do this twice. Positive 4 to that side. Positive 4 to the other side. I need to create my zeros. I can delete that. Delete that. And I have positive 1x is equal to 3. And I can always check this answer by simply plugging it back into where I started in the equation. So negative 4 plus 3 is equal to negative 1. That would have to be a true statement for all of the work that we've been doing here to be correct. And lucky for us, that is a true statement. Therefore, our process is correct, and we can move on. Like I talked about in the last video, many of these problems, you might be able to get them just using critical thinking, but I want to make sure you understand the process, which means we need to visually represent what we are working on, which means it might take a little bit of time to master, and that's okay, because if you have any questions, please let me know.